Again, Bal Vigan Bharti with mentor Avilas Sarkar. Now, in this video, we'll start from problem number 31. Problem number 31 on time and work. It says, now you can see the problems are going bit tougher than the earlier. That as usual, it is not there. You can go with the same flow. It has some twist. You have to take that twist in consideration. So concentrate more as you have concentrated till now will be essential, and it is essential at the same time to build your concept, your ability. So unless you concentrate more, or you will be lost somewhere, means there is no use of doing such putting such effort for this kind of thing. I am solving too many problems so that all kind of variety you can get, and you can learn the different aspect of any subject. So be attentive to the classes where I am just trying to deliver as much as possible. Okay, the ratio of efficiency of A is, sorry, I'll put symbolic. It is given A is to C, and that is the symbol is giving the same thing, is equal to 5 is to 3. Sometimes I use shorter way of describing problem because that will save my time on writing the problem. Rather, I will take that opportunity to describe it in more time and explain it in very elaborate way, rather putting so much of thing there in writing. Okay, the ratio of the number of days, the ratio of the number of days by B is to C equal to 2 is to 3. A takes 6 days less than C for a job when they do it individually. Okay, B and C started the job. B and C started a work and left after 2 days. The number of days taken by A to finish the remaining. Okay, so this is the problem where, let me read it out together to understand. You can say together we have to understand the problem first. The ratio of the efficiency of, and I will put the things in one part of the board so that all the information can be gathered in one place. Okay, reading it is very difficult to grab all the things together. Rather, if we put it in one side of the paper or the board, in one shot you can see the information. Okay, so my way of doing it all the same way. The ratio of efficiency of, so I am putting in symbolic way. So this is your first information. You know the symbol of efficiency is efficiency A is to C. The ratio of the day, so D I will take the opportunity to represent the day, is to C, it is equal to 2 is to 3. Okay, A takes 6 less than C, 6 days less than for a job. So the day of A is DC minus 6. whatever C is taking, he is taking less than C for a job. Now up to this equation is okay. B and C started a job, or later will come. Now from this equation, let is assume this is the days B and taking. So we can say dB is 2x if I assume. So DC will be 3x definitely, and that of dA then will be, it is related to DC, that means 3x minus 6. So these are the equation. Now from the first equation, as efficiency of A by efficiency of C is equal to 5:3. Now what is efficiency then? Efficiency is equal to the complete job by day. Efficiency into D, or the rate of work, this is the same as the rate of work, into D is the complete job. So efficiency and the day are in inverse relation, so I can put it DC by DA is 5:3. Now DC and DA, you know, DC is what? 3x minus 6, 5:3. Now you can cancel 3, will get 2 here. So this is ultimately x upon x minus 2. So from there, if you calculate 3x is equal to 5x minus 10, so 2x is equal to 10, so x is equal to 5. So if x is equal to 5, I will get it is 10, this is 15, and this is equal to 15 minus 6, 9. So all this information is gathered, this part is done. Now as you know, they have started, who has started? B and C started together. How many days they work? 2 days. So the part of job done by B and C in 2 days, this will be my first term. Now if it is the first term, so how much they do? 2 days into their efficiency, that is B is doing 1/10, and who else? C is doing 1/15. This is the case. Fraction of job they are doing individually in one day, that together they are doing in one day this much into 2 days. So this is the equation 2 into, this is 33 plus 2, that means equal to 10 by 30, that is equal to 1/3 job they did in 2 days. So what is the remaining job? Remaining job is equal to 1 minus 1/3, that is equal to 2/3. Who did this? Your partner A. After they left, A doing. So remaining job done by A in how many days? The complete work remain is 2/3 fraction is remaining. In what efficiency they will do? A is doing 1/9. This is his efficiency. So job upon efficiency will give you the time. So this is 9 into 2/3, 6 days will be the answer. Understood? Okay, I'll move on to the problem number 32. 32. Ten men I take a lesson for a man and want to complete the job. How many days will require one man to? So fine. So let me take this problem. Okay, it will come on board. 10 men and 15 women together can complete a work in 6 days. It takes 100 days for one man alone to complete alone to complete the same job, the same work. How many days will be required? How many days will be required for one woman alone to complete the same work. Okay, fine. This is bit easy than earlier problems, but still the process that you have to adopt is very important. You can do it many ways that I can see. You can go with the unitary method, you can go with another method, but what is the shortest and sweetest method, that you have to understand. If I assume that let the efficiency of women, efficiency of men and efficiency of women is represented by this. So 10 men working for 6 days, I assume it efficiency be with a letter. I am assuming this is M for efficiency the men and that of woman is W. Just for symbolic easiness, I am putting it in a letter form, so that will be easy to write and to understand it better. Means visually it will be very means comfortable, you can say. So 10 men with the efficiency of M and each man engaging 6 days. This is the fraction of job a man can do, clubbed with the 15 women with the efficiency of W working for, actually this has to be written in this form, sorry, efficiency M and number of days engaged by men is 10 into 6, this much days. Efficiency time, complete part of the work they did, the men, along with W efficiency number of women 15 and 6 days engaged will do a complete job, that is equal to 1. Okay, now this is my first equation. Now you can even reduce it if it is needed. So ultimately this is 60 M plus 90 W, this is equal to 1, is your first equation. It takes 100 days one man alone can complete. So now this case efficiency of men is, we are talking about, this is the efficiency of men. How many men working? 1. How many days working? 100. He also can complete this complete job in this way. M is the efficiency, 100 is the days, then one person is working, can complete the complete job. So from there, M is how much? 1 upon 100. So if we put it here, 60 into 1 by 100, that is equal to 90 into W is equal to 1. So what is your W then? 90 W is equal to 1 minus 6 upon 10, that means 3 upon 5. So that is equal to 2 upon 5. So what is W? 2 upon, this is equal to 5 nines of 45. 5, this is the efficiency of women. Efficiency of men you already know, efficiency of women you come to know. So how many days it will require? So this number of days required for women, just reverse of the efficiency, that means 225 days. This will be your answer. Understood? Okay. So I will move on to the problem number 33. 33. This is just easy. So I'll move on to the next problem. Let me check any other good problem is waiting for us. A is 30% more efficient than B. How much time will they working together take to complete a job which A alone could do in 23 days? This is also very easy problem. A and B can do a piece of work in 40 days and 50 days if they work at it on alternate days when A beginning on. This problem is a bit different. So I will take this, okay? What it says, A and B can do a piece of work in 40 and 50 days if they work at it an alternate days with A beginning if they work at it an alternate days with A beginning in how many days the work will be finished. The work will be finished. Okay. Fine. A and B can do a piece of work in 40 and 50 days. Now from there, the efficiency of A and B can be calculated easily. This part can be done in first instance. This is 1 by 40 is equal to 1 by 50. This is done. Now the thing is that if they work at it and alternate days, so and A is starting first, so B is doing second, so this 1, 3, 5 like that. Here A is working alternate days and 2, 4, 6 let's say doing by B. Okay, this is the case. So if I say in the consecutive day how much they did, if I can calculate this and my total job is 1. So let me check in one pair of days, the consecutive days, you can say one pair of consecutive days they did. How much they did? That is equal to 1 by 40 plus 1 by 50, isn't it? So how much it will be? 40, 50, 200. Let's say this is 5 plus 4, this is 9 by 200. Okay, this much they did. So now you tell me, if it is 9 by 200 part they did in pair of, so how many such pair is possible? How many such pair is possible when I will multiply this and I have to reach 1. How many such pair is possible? Means I have to add a 9 by 200 like that plus 9 by 200 like that. So only the numerator will be added. So how much will be very near to 200? So if I divide 200 by 9, 9 to the 18, 20, 9 to the 18. So then after I have to put something below 200. So this will be the how much days, how much pair of days needed? The pair of days needed is equal to 9 into 200 into 22. So that means 9 to the 8, 9 to the 8, 9 to the 8, 9 to the 8, 198. So the remaining job will be after this pair, this is a pair, that means I am taking together. So this 22 pair is over. Then after that the remaining job, after 22 pair of days, after 22 pair of days, remaining job is equal to 1 minus 198 by 200. So that is 2 by 200 part, that is 1 by 100 part is remaining. So 1 by 100 part in the after pair of that, the next day will be A's part. A will do. So how much A will do in a day? 1 by 40. So 1 by 40 is less than 100, 1 by 100, or which one is less? 1 by 100 is less, 1 by 40 is less. 1 by 40 is more than 1 by 40 is more than 1 by 100. So what A can do in a day is not left with this much job. So definitely the remaining job A will do. The finishing job after 22 pair, the remaining job is less than A's days work. So what is the need? How many days the work will be finished? So 22 into 2, that is the 44. In 45th now days, whatever time taking in that days, if it is not even utilized, but that day will continue 44 plus, that means at least 45 days. So that job will continue for 45 days. Understand? Because the fraction it is remaining, A can complete maybe within some hour, but days being utilized now. In that day, who is working? A is working. So 44 pair of days, then after one day, the remaining job will be completed by A. So in 45 days, so my question is that not in hours, they are asking how many days the work will be completed. That definitely we complete in 45 days. Understood? So here I will end my this session. In the next session, I will move on to the problem number 23. So till now, goodbye.